This is part 6 in our series of lectures on proofs of theorems on finite sets. And in this lecture we're going to talk about the cardinality of the union of two finite sets. Here's the theorem that we're going to prove. If A and B are any two finite sets, then their union is finite, and the cardinality of A union B is the cardinality of A plus the cardinality of B minus the cardinality of the intersection of A with B. So this is a more general theorem than the one we did a few lectures ago dealing with the cardinality of the union of disjoint sets, and it shows us that this correction term is what makes things right in the general case. In order to do the proof, the idea is to figure out how to write A union B as a disjoint union and then make use of the theorem about cardinalities of disjoint unions. So let's draw a Venn diagram to see what might work. If we draw two sets A and B, and then this denotes the union of A with B, but it suggests that we can rewrite the union as this part, union this part, union this part, and that's then a disjoint union. So what are these various parts? Well, this one here is the set theoretic difference A minus A intersected with B. This part, of course, is just A intersected with B. And this part is B minus A intersected with B. Okay, so the sketch seems to indicate that if we take the union of these three sets, that we get A union B, but the benefit is that this is now a disjoint union, and therefore that tells us that the union of three finite sets is necessarily finite, and furthermore, we know that the cardinality of this whole thing is the sum of these three cardinalities. Now, these outer two ones, those are set theoretic differences, and this is a subset of A, this is a subset of B, so we have a formula that says that the cardinality of this difference is the cardinality of A minus the cardinality of that. The cardinality of this one is the cardinality of B minus the cardinality of that, and so if we add up the three cardinalities that we get, we'll see that the cardinality of A intersect B cancels once, but there's one extra one, a minus cardinality of A intersect B, and so we get exactly what we're looking for. So that's the idea of the proof. Let's now go back and fill in all of the details. Okay, so this was the idea that we picked up from the picture. So we have to convince ourselves that each of the pieces in this union is finite. And so we're going to use the theorem that says that any subset of a finite set is finite. That's something that we did in an earlier lecture. So how are we going to use that? Well, A intersect B is a subset of the finite set A, and therefore it follows from the theorem that A intersect B is finite. We're also going to make use of the theorem that says that the difference of finite sets, one of which is a subset of the other, is finite. That's also something that we looked at in an earlier video. So therefore, the other two terms in the above union, in other words, this one and this one, are also finite sets. So I think we're now ready to write down the details of the actual proof, the formal proof. Why don't you put your video on pause and see if you can write up the proof of the theorem, and when you come back, you can compare your answer to mine. Okay, here's my proof. We have that A union B can be written in this way. Since each of the terms in the union is finite, it follows that A union B is finite. So I'm leaving out a few details here. So I've used the fact that a subset of a finite set is finite, so that makes this finite, And I've used the fact that the set theoretic difference of finite sets is also finite, provided that the one you're subtracting off is a subset of the other one. So now it follows from the theorem dealing with cardinalities of pairwise disjoint finite unions of finite sets that the cardinality of A union B equals the sum of these three cardinalities. Now we're going to use the formula from the previous lecture that says that the cardinality of this difference is equal to the difference of the two cardinalities, and a similar formula for the cardinality of this one here. So now we're ready to complete the proof. The cardinality of the union is the sum of the cardinalities that make it up. This one is this difference here. This one we just copy down again. This one is this difference here. And now you see, these are just numbers. And this number gets canceled off, and we're just left with this. And that's what we wanted to prove. That completes the proof.